Good morning, everybody. It's Peter here from AJS and also representing our sister company, G&A Warburtons in New Zealand. Welcome to viewers all around Australasia, and today we're taking you into a jeweller's workshop somewhere in Australasia, and that is this week to sunny Geelong and the even sunnier Chris Sherwin. Welcome, Chris.
Thank you, Peter. Welcome, everybody.
Great to have you back on board, Chris.
Yeah, it's nice to be back.
Yes, you've got a very active workers bench there. So I'm sure we're in for fun and games today. The subject of today's demo is making threads with a tap and die. And you're going to show us that and their uses in jewellery. Would you like to give a little bit of a summary of what we're going to get up to today then?
Yeah, thanks, Peter. Welcome, everybody. Today, we're going to be looking at making threads in jewellery using a tap and die, and I'll demonstrate those in a moment. And I've got a couple of samples here that I've got pre-prepared, and we might even get one finished and made today. So, yeah, exciting day. It's quite technical, and hope I don't sort of overpower anyone, but I think you'll find this fascinating.
They can always re-watch the replay if they get overawed.
Right.
But
That's
so
right.
where do we start then, Chris?
All right. Well, I'll start by introducing the tools, so everyone
Excellent.
knows what a tap and die look like. This is your tapping tool. There's a holding device. You can buy this from really good tool suppliers. The tap is actually a threaded tool which taps into the metal to form the nut, if you like, of the piece that you're making. So that has quite a nice little thread to it. 3 little flutes. Looks a lot like the sort of tool you put into your flexi drive, but this has a thread on it, and it's a special hardened steel, and that will actually cut the thread for the threading part, if you like.
Okay.
And that tool goes into this holding device. Holding device just has a little connection point, and the handles screw in, and it just holds your tap at 90 degrees to what you're cutting into. So you can see the little flutes there, and there are tiny little threads, and the flutes allow the metal that we cut off to go away and clear from the cutting point. So that's your tap. And the dies, this is the die tool. Again, it's a holding device. If I sort of unscrew it, I'll take the actual die out. The die is just a circular tool, and that die actually cuts the thread into your wire shaft. So that's actually for creating the thread. That's your die, and the tap is for actually cutting and making, if you like, the nut end of your piece of jewellery. So you need the 2 tools. They go together. They pair up. I'll put that back together again.
So what's the range in sizes that you can cater for with these tools, Chris?
Well, right down to sort of almost micro level.
Wow.
So this one's quite large, if you like, from a jewellery perspective, because I do a lot of silversmithing. So I've just got to relocate this while I'm thinking about it.
Yeah.
Yeah, I'll show you. I'll just get this relocated, so we sort of stay on track with that. Just locking that back into the tool securely, because it's very important how you treat these. These tools are quite expensive. You're probably looking at a tap and die set like this is probably $65 to $85 just for one tap and one die, and they do break very easily. if you don't set them up properly and care for them properly, they are quite fragile.
Mm-hmm.
So that's my 3M, so 3mm one, and that's to set together the actual die itself and the tapping tool, and you can imagine they basically will fit together. I could actually feed them into each other if you like. But you can get the jewellery scale. I'm sure you can probably get these through MJS. You can get these little plates that have multiple holes in them, and you can do from this one probably from about 4mm down to around about 0.8 of a millimetre. So there's quite a range of sizes. That plate is effectively this tool. So you've got multiples of taps in this tool. This is a single tap. This is multiples in one plate. And the dies obviously work to that tool. So this is a number 2 die, very fine. Hold it up a little bit closer. That's probably about 1mm. And that will fit into the number 2 hole in this plate. I'll just place it in for you. That screws in down here. Just thread that in. And you'll see that now threaded and sitting in the plate in the second last opening. So that's 1mm. I imagine the last opening is about 0.8, Peter.
Okay.
And then you would work your way up different sizes. So for every hole across the middle here, you have a tap that fits into it. And you notice that in this one, this particular plate has holes through the center, which gives you, they're not actually threaded. It gives you an idea of the size of the wire that you need to use. And either side of those holes, that center hole, you've actually got a die which cuts your thread. They've put 2 on this plate. So I guess if you sort of bugger one up, you've got an alternative.
Looks like that could double for a crib board. There, Chris.
Yeah, it's pretty good, isn't it?
Yeah.
It looks quite sophisticated, but there's actually, despite the fact that you see double holes up here, the actual cutting part is in the middle of those 3 holes. So they're sort of like pairs of 3.
Yeah.
Again, the side holes sort of on the diagonal, they're for clearing the swarf away. So the swarf is just like on a lathe. It's the material you're removing.
Yeah.
The actual cutting section is right in the middle. As you can see, that one tap is in the very middle of the 3 holes. And that's the bit that's going to do the cutting. So that's your tap and die. So, yeah, this is obviously a much larger tool, something to hold on to because I'm cutting usually quite large threads. But if you're doing the very small micro ones, the jewellery scale, you're going to be using a tool of that size, which is multiple tools. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You've got a dozen different sizes on this particular tool. And obviously you've got a dozen different taps. I've only got the one out because I'm just using the one today. So this is jewellery scale, and this is obviously more of a larger jewellery silversmithing scale.
Okay.
Okay. Now, let's talk a little bit about the tools. These are obviously, as I said, expensive. A set will cost you about $85 roughly, and might go up from there. You probably get cheaper ones. They are made from hardened steel. They are very precision. These ones are Sutton ones, which are, I think they're an Australian one. So you get a tap, you get a die, and then you get a tap, and separately. And sometimes you can get a pre-tapping tap. So you can drill your hole, pre-tap it, and then go in with a final second tool to sharpen it right up and get it precisely right. Now, these tools are clearly designed for steel or brass. So that's why they're hardened the way they're hardened. So you could clearly make brass threads. You can make steel threads. You can even use titanium, although titanium will blunt your tap and die. But for jewelry alloys, they're fantastic because there's virtually no wear on them. They're very strong, but they are brittle. They're very easily snapped. So you do have to be careful when you use them, especially your tapping tool. If you are wiggling around too much with this tool, you're not aligned properly when you're threading, it will simply snap. And that's nothing but aggravation because you've broken the hardened steel into your jewellery, and your $60 or $50 tap is now worthless and you have to go and buy another one. So they're worth looking after. I'm not sure what these sets cost. They're probably, a good Swiss set might cost you $300 or something like that. So you need to do a few jobs to justify having those sort of tools. But they're brilliant. They're really good. So what are we going to be doing? So I've made a couple of these. These are ring stands. And I've done this deliberately to show you that you can join elements of timber and silver. This piece actually, we'll pull it apart in a second. So your ring stand, your ring goes on the top like that, and it sits on there. You can put it on your bedside table or whatever you want to do. There's your ring on there. And I've put some really beautiful timber in here, 2 lots of timber, top and bottom. And I've obviously got lots of silver elements. There's a cast section, a Roman column, which is sort of my style, a base, a top section, a thread. And if you look at the very bottom, that's how it all comes together. So I've got a little nut there, and you can just see the center of where the wire comes through, which is the thread. And that's the bit we're going to make today. So that whole piece is set on a single thread.
Okay.
Otherwise, to join all this together, I'd either have to glue it together, or I'd have to have a whole series of pins. Every single piece would have to have a pin going into the timber, going into the next bit, going to the next bit. And by having one single thread, if I turn that, this whole piece will swivel and come apart from the bottom. So let's show you how this is done. Tighten that up again. Straighten that up. And that's our ring stand with timber and metal. So it just shows you straight away that you can really diversify how much you can produce as a jeweler by being able not just to work in metal, but also combine metals, combine plastic, leather, timber, all sorts of things you can bring together by threading and joining. And that's probably why one of the reasons why you would do this is because you can't solder. You can't solder onto leather, you can't solder onto timber. But if you can thread things together and bolt them together or pin them together, you've really increased your repertoire.
And it's a nice mechanical fastening that's not going to fall apart.
Lovely, lovely mechanical fastening. It's a really good way to join things. So the other thing I'm going to show you today too is making more the jewellery scale. So this is a butterfly, which I'm going to thread. So this is a butterfly for the back of earrings. It's just got a couple of little scrolls on it, a piece of chenille, and a disc. And if I can tap that successfully, then I can make a wire post for the back of my earrings, and then the post on the earrings will screw into the butterfly, and they'll be secured at the back of the ear by threading, because some people do like threads on the back of their earring post. They just put the diamond or the stud through the ear, and then they just twist the butterfly at the back, and it secures the post without it falling off. And I guess if you're wearing carat diamond studs, which I don't, you might feel that they're better protected by having a thread. All right. So how is this done? Well, there's a lot of calculation involved, and I won't get too deeply into that because I'll let you work that out. That's what learning and experience is about. But we'll get back. We'll cut a thread straight away just so you see how it happens. And I'll make a nut for you. So this is a second piece that I've made. That needs to be drilled. That's okay. So this is the same as the first one, if you like, the ring stand.
Yep.
And this is my timber base component, which I'm going to put a concealed nut in the back of. And previously, that was the one I showed you before.
Yep.
Then I have a silver base plate. And that's...
I'll just go to the other camera there.
Yeah, it's a little flat plate, 1.5 thick, and I've put my hallmarks on there, and I've drilled a hole all the way through it. So that will be the second base component. Then I've actually put a disc inside. There's just a little disc inside to tighten up the thread itself to the circular opening. So I don't want this sort of flicking around inside.
Yep.
And by creating a disc, it will sit in the center. That's my central silver column. Obviously, this is a very expensive ring holder. That's quite a heavy 150-gram silver column, which I've created. And then I've got a little cushion shape and a cast finial, and I've soldered my wire in here, which I'm going to thread. So this goes all the way through, and this will have the little thread section right down the bottom here, and we're going to do that right now.
Beautiful.
Obviously, I've calculated this all out. It's ready to go. I know the length is right. So what I've had to do, I've had to get my vernier calipers. I'm going to put on my specs so I can see what I'm doing really well. And I've calculated the width of my wire, and it is right on 3 millimeters, because the actual die that I'm going to use is a 3 millimeter die. So the external part of the thread will be 3 millimeters wide, and it will clearly cut into the wire, and it will upset the wire to the point where I've got a perfect 3 millimeter thread. So when you do this, you need to think a little bit about the hardening properties of your material. So in silver at this scale, this is fully annealed because it's soldered to this finial. But if I'm producing later a small earring post for this butterfly, I'm going to use half hardened wire. And the reason is that the force in tapping down on your wire, if the wire is extremely skinny and fully annealed, as you turn the die, it will spiral your wire and the wire won't be cut. So it is important to think about the scale and size of your wire before you start cutting. It's very important to have the correct diameter wire. So I can't use a 3 millimeter tap and then use a 2.7 millimeter wire, because I won't cut a proper thread. It won't be fully out to the 3 mils. Alternately, I can't use a 3.2 mil wire into a 3 mil tap, because there'll be so much force required that the swarf will just go everywhere, and it'll either break the tap or I won't get a sufficiently accurate cut. So it is important to think about how hard your wire is, the diameter of your wire, and it's the same when we do the tapping of the nut. If you don't drill a sufficiently large enough hole and you start tapping into a little disc of metal, you'll end up snapping off your tapping tool. So size is very important. Okay, so to start with my die and to cut this thread, I'm going to put a slight point on my wire, because it will introduce the wire into the tool at the right angle. I don't want to be coming in with just a flat end. The tool cuts progressively through the depth of the tool to the full diameter. So that means that the face of the tool is the perfect size, but 8 or 10 mils down where I start cutting, it's actually a very open thread. So the thread gets tighter and tighter and tighter until you get to the face of the tool, and that's when it gets the perfect thickness. So I can afford to have a slightly pointy wire. Helps me introduce it into the tool. I've just put a slight point in that wire. Yep. And a little bit hard to see. I'll pull it back a little bit. It's a little bit, yeah, a little bit of a chamfer on the front, so it's not blunt on the end.
Yep, we've got that.
I'm going to get the tool, make sure it's the right way around. So where the writing is the final cut, and away from the writing is the starting cut. Make sure the handle's tight, that the tap is in position, the die is in position properly. And I start introducing that tool. So I'm going to just do that on this camera because it's otherwise I'm going to have an error.
Yep.
And I'm perpendicular to my wire. So I'm turning gently, pushing gently. Wants to start to grab. Turning. I'll have to put this in the pliers in a second. And I'm going to do it vertically. That might help me a bit. Do that vertically. Start my cut. It's important that you're careful to start your cut accurately. A little bit more force. I might have to just put a slightly sharper tip. Now it's starting to grab. So I'm trying to make sure that that's nice and perpendicular. It's a little bit off angle. Going to grab this with my pliers, stop it from twisting. Correct it a little bit. And just keep checking that I'm in a vertical position or perpendicular to the die. That's not right either. You can see that's crooked. So I'm going to back that off. Going to go back in again. Sharpen that up a little bit more. And obviously the start is the most important part. That's
you can do a restart there, Chris, but if you go too far, I assume you've gone too far. Yes, in an incorrect direction. If
you're terribly crooked, you'll just end up chopping the wire off. Or that's right. It's easy enough to restart, but if you get it wrong and you go too far, you probably damage the tool. Sorry, I can't quite hold that the angle, but you know what I'm doing. I'm trying to get as perpendicular as I can on this wire. It'll sort of semi self-straighten, but you'll want to do that, but it's amazing what your hands will do. I think I'm away now. I'll just cut a little bit further here. You probably can't see me. It's a little bit off, but I think it'll correct from there. Yeah. Go. Still just trying to find its way. And now we're starting to really bite in. This is going fine.
So how far up that wire do you need to make that thread?
Probably about 5 to 10 mil.
Okay.
I'll go further.
Mm.
I needed about 3 or 4 mil for the actual nut itself. Okay, so I'm going. It looks crooked, but it's actually fine. It's just a slight twist on the wire. So I'm going to hold this up so you can hopefully see.
Sure.
We swap cameras where the swarf is coming out of the tool itself. There we go. So you can see the wire going into the threaded part of the tool, and you see all that sort of curly stuff going out into the three little retreating areas.
Yep.
That's the swarf being cut away from that wire. And if I look at the face end, then I haven't come all the way through yet. I've got to work my way down. You can see the gap there. There it is.
Okay.
And I'm obviously going to try to work my way all the way through there, probably about 8-9 mil of the tool, until we've got a really nice thread cut on there. But you can just see that swarf coming up. If you've got any questions, just ask away. I'm sure Peter can put them through to me.
Yeah, I'll just take this opportunity of welcoming our crew watching online. If you'd like to say good day by introducing yourself and letting us know where you're from, that'd be good. And even better, if you've got a question for Chris. Have you done this before? Is it something you're looking at doing?
So what I'm going to do now is I'm actually going to back this off. If you're working in steel, there's kind of a formula of it's about, I think it's a turn and a half forward and then 2 turns back, and then a turn and a half forward and 2 turns backwards. And
it's like life, really, Chris.
So I beg your pardon?
It's like life.
Yeah.
2 steps forward, 1 step backwards.
It's a bit like that.
Yeah.
And it just enables the tool to clear the swarf so that the swarf doesn't get cut into the thread. Fantastic. That's going beautifully. I'll just show you that thread. So if we go to that other camera, you'll just see the thread being cut there. I'll get it.
We can.
Closer. Is that
yeah, that's good. Yeah, that's in focus.
And you see a little bit of swarf sticking out there. There you go on the side. And I've only cut down about 3 millimeters, but you can see that the thread is actually starting to be cut on the end of that wire. There we go. So I'm going to go back on again very carefully. Anytime you remove it, you've got to make sure you go back into the same part of the die. Turn it very gently. There we go. It's picking itself up. It's finding its natural threaded pattern, and we get down to the coal face, so to speak. And it's now tight again. And now I can start continuing on. So just keep that perpendicular motion. So with the silver, I just know from experience, I just can continuously cut because it's quite a soft material. But if this was steel, I'd be backing back. Perhaps if it was a hardened brass, I'd be backing off and then coming forward again. Just allows that swarf to clear. Then we're cutting again. I can feel it cutting. Down we come.
Just while you're twisting again there, like you did last summer, Chris, I'll just introduce, say good day to Greg from Harvey Bay, Carol from McLagan, and Jim. And Jim suggests that he uses a drop of WD-40 when he's doing this.
Yep, great idea, especially if you're working with ferrous metal like steel. Again, I don't think it's going to bother you in precious metal. It's a little bit of lubrication. Yep, definitely. Silver's a bit of a beast because it's so sticky, but yep, WD-40 works fine.
Thanks very much for your comment there, Jim.
Yeah, someone who's obviously cut some threads before.
Indeed.
So I'm almost all the way through. So I've got about 8 mils I've done. Just back it off one more time, just a little bit. I can see the swarf coming off. And of course, when you're doing this, it's work hardening the material incredibly so that because silver's not a great material to thread, let's face it. So really, if you're working in gold, it's ideal. You're creating real hardness. Yeah, silver's a very, very soft material. So it's just difficult to get your work hardening right before you start, if you can work harden. And now I've cut all the way through to the face of the die. Well, yep. I'm going to hold that up to the other camera. So just show you the back end. You'll see all the swarf in there. That'll come off once I release it. And if you look at the face of the die now, I've got my little 3mm thread coming all the way through to the front, just about flush with the front there. And I've got plenty of thread there for the little nut I'm going to pop on there. So I'm going to take that one out, release that carefully, back my way back. It's nice and firm all the way out. So yes, you do have to overcut slightly, because until you get to the face of the tapping tool, you won't have the correct thread pattern. And out it comes. Just clear that little bit of swarf away. And I've got about 8 or 9 mils, almost 10 mils of thread there. Now, really nicely threaded and ready for me to make a nut for the other end. Doesn't want to focus. That's the problem with these iPhones, isn't it? They just don't want to focus well at close range without the macro. Peter and I were talking about that the other day.
Yeah.
But that's your thread there.
Just pop your hand behind the your other hand,
because it's focusing on my. Yeah,
because it'll be trying to pick up a lot of the background.
Trying to pick up my hand, but you can see the thread there.
Yeah.
Get a bit closer. That's great. There you go. Nice little thread, about 8mm long, and then you've got your 3mm material with your 3mm thread at the top. And yeah, lovely thing. So now we have to make the other side, which is the nut. And I'm going to do that into a piece of sheet, which is about 2.5, I think, 2.5 mil. You want to have, it's actually 2 mil. You want to have about 2.5 to 3 turns of the thread in contact with the nut end, if you like. So you don't want to use a 1 mil sheet and then only have 1.5 turns of thread, if you can help that, because you just don't have enough gripping onto your nut, and you'll basically thread the nut. You every time you tighten it up, you'll put so much pressure on the actual thread in the nut that you'll ruin it. So you need to go a little bit thicker. So you've got 2 to 3 turns of that thread are always in contact with the thickness of your holding material. And that's why nuts are 3, 4, 5 mils thick when you buy them. So just put a little circle on there. It's just a rough bit of metal. Rather than cut that into a disc straight away, I'm going to leave it as a chunk because it gives me something to hold on to. And now's the important part of drilling through that holding component, the nut component, and opening that out so that it's probably, I'm guessing, it's probably around about 2.5 to 2.7 diameter hole. So you don't drill a 3mm hole because you're wanting your tap to do that. Bit of beeswax. There's my wax. So that's my 1.2 through, and then I'll go through with probably about a 2 miller. Just use a ball burr. Just slowly open that out so I can put the tap down. And again, it can be trial and error. And just take my tap and double check that it's not too big. It's about 2 mil. Yeah, this one's about 2.5 to 3, so I'm going to double check that one. 2.5. This should be quite close to the size that I'm after. And as I said earlier, you're trying to make sure that you haven't either over or under drills, because if you do, you're at risk of breaking your tap. Hole in there. Might need to go a smidgen bigger. It's pretty close. Could probably go to 2.7, but I'll see if I can cut that. It's not too thick. My little tap's fallen out of its holding device. This must be a cheapie. It's not. It's one of those ones that just keeps letting go.
Yeah. So
here we go. I've got my drill hole in that sheet, around about 2.5, and I'm going to be putting that tapping tool in there. Again, you can see there's a slight taper on the front of that tool, and it tapers thin to the full width towards the bottom. So again, I've got to introduce that slowly and perpendicular. So just take my time starting the tool, and it will tend, if you've got the drill hole the right size, it will tend to, it's already slipping down this end. Got that too far in the tool. It's got a little square shaft on it. Try to tighten this up. Was never really happy with this holding tool when I bought it, but anyway, it is what it is. Hold that in the parallels, something to hold on to. So you can see if this was a disc, it would be very hard to hold on to. And here we go. It's starting to cut. That 2.5 feels about perfect for this 3mm tap. Again, nice and perpendicular. So absolutely perpendicular to the sheet of material. So I'm not going
perfect job.
Skewing angle there.
Just to answer a question from Christine, she just wanted to know about the tap and dies and AJS. We do sell threading equipment. So if you'd like to ring your local AJS showroom on 1300 852 999, they'll be able to help you out with that, Christine. And Jim's also put forward some suggestions for you.
Yeah, they're a great tool to have. They really are handy. I do a lot of large, I do candlesticks and very large pieces, boxes and whatnot, and I want to join things together with the thread, and they're just great. So I've got all the way through here. I'll just hold it up to the camera again. You can see the tip of my tapping tool is coming through the sheet, and I've still got to go a bit further because I haven't reached the maximum threading point at the bottom here.
Yeah.
So I'm just going to go a little bit further, and then we'll marry the two together. So just twisting that through. It's got a good run now. It's nice and straight, even though my tool's letting go. And you'll feel the force coming off. You see the swarf coming out. The force comes off. It gets very easy to turn as you get to the maximum diameter. And I've now reached that point, and I can take that off. Still got plastic on the back of my silver sheet here. Pull that off. Just that protective coating you get. And wind that off. Right to the top. And there you go. I've now tapped that, and I can pick up my two pieces and hopefully they'll thread together. So let's see how we go.
Live on TV.
Put that in there. And there you go.
You came through with a good. Just well done.
we're all together. So all I've got to do now is basically cut that out of the sheet to the desired shape that I want to do. And I've got the nut end to my thread. And I can put my unit together. So I've got a little bit more time. I might just do a little bit more on this. Cut this out if I can. Actually, I might leave that because you now know what it looks like. Go back to my original one. So my original piece, remember, has 2 bits of timber in it, has a knot from the top and the center section and a base section. So I'll pull that apart and I'll just show you how I've managed to conceal the nut. So that just screws off.
I'm just on the side camera there, Chris.
Yeah. So that's the thread part. Unthread that. That comes all the way out. And I've got my bits of timber. And I've got my decorative section. And I've got the little holding disc that holds that together in the decorative section. That just sort of goes in there like a little washer, keeps it nice and straight in the center. And when I finished off the nut, so this section, this will eventually become my nut, which is once I've cut it out of the sheet, you can do whatever shape you want to do. There's my base section. And finally, the last piece of timber. And in the last piece of timber, what I've done at the back where the nut goes, I've just made a little concealed little point there, kind of countersunk, and my nut actually sits beautifully in there. I don't want to drop it on the floor, but the nut sits in there flush. So when it sits on the bedside table, it's not protruding. And obviously my thread comes all the way through all of those components, right through the last one, and then into the silver at the back. And you can see it's protruding there. I've got it sitting up, but if I pull it down tight, nope, see if I've got it threaded in yet. Don't think I've got that threaded in. No, I don't. I'll use the original one because it'll be nice and straight. I'll be able to show you how it pulls up. There we go. And I can push that all the way up. You can see that I've pushed that all the way through. And if I tighten it down to the point where it's flush and pull it in, there I've got my concealed nut. Circular, but it does the job. So there you go.
Excellent. Work of art. Chris, tell us that column. Did you make that as well?
Yep, that's my famous little Roman column.
Pretty nifty.
Ionic column in silver.
There'd be a couple of hours work in that, I assume.
There's plenty of hours of work in that. That's right. a lot of hours of work in those. Yeah. And it's quite heavy. It's about 125, 150 grams. They're quite heavy. So almost finished. Let's just quickly look at this, the butterfly. So going down, a lot smaller. This is just a silver disc with about a 5mm chenier in it, or you could use a 5mm wire. And I've done a couple of nice little scrolls there just to support the wire, if you like. Just try to show it from the other angle without dropping it on the floor. You can see my little scrolls. And there they are. They're all supported nicely. A drill hole going through the disc, and obviously there's a very fine hole going through the chenier. So let's just see if we can tap that. In this case, I would hold the tapping tool, if I can find it. Where do I put it? No, it's in the tool. Take that out. I've got these great Morm pliers, which you might be able to order from AJS, but these ones have a groove in them, which is very handy. So I'm going to hold that tapping tool in the groove in the pliers. And then I'm going to grab my little butterfly and introduce the tool into that hole, and it will thread its way all the way up through that chenier, and I'll have a beautiful thread through the butterfly. Again, the hole size is important. The hole size here would be around about 0.9 or 0.8 for a 1 to 1.1 tap. And this is where you have to be careful not to snap your tapping tools, because they are quite delicate at this scale. And I would start to either use the WD-40 or a bit of wax, or I would keep backing the tool off to clear the swarf so that I can slowly move that tool into the chenier, cutting its way in slowly, spinning it backwards, coming to the cutting face, cutting a quarter turn, half a turn, backing it off. And so I would continue on until I've fully cut that thread. So eventually I'll have a silver thread going all the way through there. At the moment, I've got the steel tool going into the to the chenier. I don't want to snap it off in a hurry. So that's how that will happen. And again, to repeat, the same is true of the wire. A little bit before, while Peter was waiting for me, I've got a 1 mil wire. So again, very, very close to the size that you are going to need complete. And I then introduce that into my multi-die tool, which is there. And again, I have to make sure I end up starting as perpendicular as possible. Now, this wire, being silver, is half hard. I don't think you'd manage to do this with annealed wire, because the wire will just start spinning around and will just tear off. So again, this is where you have to think about the hardness of your material and the quality of your tapping tools to make sure that you are cutting the appropriate thread without damaging the tool. That's going along fairly well. How are we going for time, Peter?
Nearing the end. Yep.
A couple more minutes.
Yep. So if there's any other comments or questions from our viewers, that'd be great.
Please. Again, just to reiterate, it's just a great way to, you get asked by customers, oh, can you do threaded earring backs, or can you do such and such? And of course you can go out and buy them. But if it's custom made, you really want to be able to get your stamps on there and show your client that you are a really top hand maker, then it's worth being able to do this. Great job satisfaction, and really increases your skill level.
Mm.
So I'm just about all the way through with this one. And this would be my thread. So we won't get into too much into the complexities of jewellery making. A lot of the problems you have for those listening would be, once you've soldered your post onto your earring, it's probably going to be annealed. So that's quite possibly the point at which you have to cut your thread. And some people put their threads on before they solder them on. So there are always issues, as we all know, with soldering. When do you soften, when do you harden? But the main thing is you know how to make these nice little threads and these little tools. So I'm going to swing that off. I've cut that. Not that deeply, but it's a good little start. Yep, and it hasn't worked that well. I've actually put too much pressure over this wire. It started to twist. I'll show you that. Even your mistakes you can learn from. If you have a look at that silver wire, and I turn it around, but I put my finger up here. See the funny little angle it's swung off on? Look at that.
Oh, yeah.
Too much pressure on the wire. and just not holding the tap and die perpendicular to each other. So I've got quite a little kick on that. So I'll have to cut that off and start again. And perhaps pull that wire down just a little bit finer. I felt it was a little bit tight. So maybe one more hole through the draw plate will make all the difference. So there we have, tapping, taps and dies. You can create some amazing, really nice, sophisticated bits of jewellery. And the sort of things you'd use them on would be, things you can't solder on. Perhaps if you're doing some enameling or some stone setting that's very sensitive, or you're making a bracelet and you want to have multiple components that come apart without soldering, this is the way to do it. Fabulous part of jewellery production, I think. So
well done. Thank you very much for that, Chris. Thanks to our viewers for being involved today, in particular Greg, Carol, Jim and Christine. And we'll look forward to seeing you again sometime real soon, Chris, with another demonstration.
Thank you so much. Thanks, Peter. Thanks, everyone, for watching. And get any questions, just pass them through Peter and we'll try to answer them for you.